when using the t-test, evaluating the normal assumption of the sample distribution is necessary, because in t-test, we do not know the population standard deviation. So we want to make sure that the distribution is normally distributed. So in this video, I'm going to show you how we can produce a normal probability plot, and the plot I'm going to show you is called quantile plot, and how to use it and how to draw this plot in Excel. So I'm going to show you a data file. Let me share with you the data file. So what you see here is a data file of 60 observation. So I asked my students, how long does it take them to come from their home to school? And they gave several time, and this is the data files. So this is a actual observation or actual time of commuting time to come to school, and this data is not sorted. So in order to plot a normal probability plot, first thing we want to do here is this, to arrange this data into a order format. That means in the ascending order, from small to high. So that's what I'm going to do right now. I'm just going to take the data set I have, and I'm going to sort this data from high to low, from low to high, rather, from low to high. So yeah, smallest to largest, as you see here. And yeah, here we go. So we have minimum time is 0 minute, but here it is 0 minute, and the highest time we have is 105 minutes. So somebody take almost no time to come to school, and somebody takes over 100 minutes to come to school. Okay. Now the next step, what we want to do here is create a cumulative probability. So what I'm going to do here is this: I'm going to add a column here, and I'm going to give a ordered value. So let's call this a ordered value. Ordered value. So here the ordered value, and I'm going to so there are 60 observations. So this order value will go from from 1 to 60. Okay. So simply I fill the rest of the cell. Here the rest of the cell goes all the way to 60 observations. Here they are. So I assign this ordered value. The next thing I want to do is to find out the cumulative probabilities of this order value. So I'm going to create a cumulative probability. So I'm going to create another column next to this order value, and I'm going to call it cumulative probabilities. Cumulative probabilities. All right. So to create cumulative probabilities, so what I want to do here is to take the first observation divided by, so there are 60 observations plus 1. Now, why I'm doing this is because I'm creating cumulative probability. So basically, it means that what's the probability of getting order value 1 or less? So the probability in this case will be 0.0163. So that's what cumulative probabilities are. And I'm going to, we don't need to have so many decimal places. If you want to shorten the decimal place to, let's say, 4 decimal place, you can always change into a decimal, into a few decimal places. And then I'm just going to fill up the remaining cell using the formulas. Okay, so my number goes anywhere from 0.0164 to 0.9836. And so, for example, so what's the probability of um, that the number is 60 or less is 0.9836. So what's the probability of the number is more than 60? So it will be 1 minus 0.9836. Okay. And that number would be, if you subtract from 1, would be 0.0164. Okay. And which is exactly, you see here, 0.0164. Okay. So we have created these cumulative probabilities. So one thing you are noticing here is this. So what we're going to do next step is to so these cumulative probabilities are our theoretical normal distribution probabilities. Okay, and we're going to compare this theoretical cumulative probabilities with this commuting time. So we have created two sets of data. One is the actual value, the commute time, which is our random variable, the x. We can call it a random variable. We can give the name random variable x. And that's what we do really. And then what the next step we will be doing here is to create a z value. So the way we are going to create the z value is using a z distribution function, which is available in the Excel function, and the function is called norm inverse function. So first I'm going to write down the z value here in this column, so we know what we're doing. Z value, and this will be norm. And once we write down this function and we select the cumulative probability, so this will give us the z value for that cumulative probability. Okay. So if I want to see a little bit more about what this function tells us here in Excel, you notice that this norm inverse function, it's a probability corresponding to that cumulative probability we just calculated. Okay. And then simply fill in the remaining cells. That's what is filled in. And yeah, so we got here the lowest value is 0.2134, and you guessed it right. The highest value will be plus 2.134 because it's symmetrical normal distribution curve. So it follow the normal distribution properties. Okay, because this is theoretical values. Now, next thing we want to do here is to compare our z value, which we just calculated, with the actual value we have. So we select these two column, and in Excel has a chart option. So here's insert, and you said they have several charts. So I'm just going to click on this chart here, and you notice that it's calculated chart for us. So right now the axis line is going through 0, but if you want to bring the axis line at the very end, which will be a -30, so we can do that. So double click on the axis line, it will shows up the various option, and the minimum is -3, and the maximum is 3, which is perfectly fine. One thing you notice that in the excess value, it's 0 right now. So it was automatic, but if I like to go and put it to a -3.0, and you notice that the line will go back to the -3. And of course, you can always change the if you like to change the decimal places. Right now it's a 4 decimal places. You want to, let's say you want to a 1 decimal place or 2 decimal place, you can always change it. I prefer to have 2 decimal place, so I just did it. So I got 2 decimal place, right? So how do we know whether the curve we just plotted right now is normally distributed or not? So one of the way I do it is I also draw a reference line. So the one of the quick way I think is to draw that reference line is to, if you right click on your on your dots on your scatter plot and add the trend line, it will give you a very quick reference line. Here it is. So you notice that there's a reference line. So I can compare this reference line with the actual distribution I just plotted here. So you notice that there is some departure. Not all the points are on the straight line. So there seems to be some departure. So this indicates that there is some deviation from normality. Some of the data points are above the reference line, and that indicates that we have a positive skewness actually. If you see that the probability plot, the curve is below the reference line, that indicates a left skewness. And also, if you notice that there is some sort of a shape showing up on your plot, that also indicate that there's some sort of other distribution, perhaps a rectangular distribution or some other type of distribution present in your data. If you take this quickly this data set and you do some of the quick statistics, for example, and some of the quick statistics is including your for example, mean or the standard deviation, for example, skewness or kurtosis. So if you remember, even without drawing a normal probability plot, if you see that the mean and the medians have a similar values, that also indicates a normality as well. So we can quickly compute our mean and median, use data set, and we can see they are the same or not, for example. And obviously, if you see a positive skewness showing up from this stats when you compute the descriptive statistics, that also indicates. So I'm just going to quickly show you how to, for example, from this data set, I'm just going to compute the average value. Okay, so this is the average value, and the average is 36.833. So that shows that on an average, student take 36.83 minutes to come to school. So that's the average time, the mean. And if I compute the mode, rather median actually, if you compute the median, and it is 30 minutes. So you notice that the mean is definitely way higher than the mode. So that also indicates that there is a skewness, a positive skewness, and of course we can also calculate the skewness. So here is the skewness function. One thing I like about the Excel is they have very several functions which can compute some of the statistical descriptive statistics very quickly. So you notice that here the it is 7.76 approximately is the skewness of the data. All right. So yeah, so this is one of the easy way to compute your normal probability plot and check for the normality assumption. And yeah, if you want to show a nicely done, you can have a nicely labeled. So in this sheet, you can see that I have nicely labeled all my work. I have a plot. I also labeled, and my plot also nicely labeled. So this way it looks nicely presented.